another draft physics video presentation. Voice problem, I guess. Uh, anyway, Franklin who on magnetism, but unfortunately we can't really just do magnetism because the underlying concepts get in the way. So, I think the only way to have the conversation is to argue what the evidence is and then make suggestions, I guess, to some premise. But clearly, Franklin doesn't understand my theory much, and so we paraphrase it pretty poorly, in my opinion, and makes arguments that I would say were kind of irrelevant because I'm not arguing what he's claiming I'm arguing. So I guess I'll just quickly point out that I'm arguing that there's only two things in the universe: force and matter. So there's stuff moving the speed of light that's really discrete and tiny. It makes magnetism, it makes gravity, it makes light. Okay, so anything moving the speed of light is being made by something I would call force. Okay, and it has two kinds to it. It's not really important to understand that, but there's a force, okay, that just affects electrons, and there's in the sense of giving them momentum, and then there's a force that just affects the protons. So you can say red and blue, however you want to understand it. And the only force that makes photons is obviously the red force. If the electron force is red. I usually use blue, frankly, so let's stay with that. Photons are just that force at a frequency. If the force isn't at a frequency, then it's just radiation. It's just pressure in the universe, you could call that gravity because it ends up moving electrons and jiggling them about, and that uses up some energy. And a magnet is basically just taking the mixture, purple, that's in the universe, and it's converting it into some segregation. That is, it's creating a pattern out of it. Now I would argue that's what a magnet is doing, is creating a pattern, because as Franklin points out, the only difficulty in understanding that the electric force is the same as the magnetic force is the fact that they don't seem to, they do everything the same, in the sense if I could build an atom, if I could take an electron and proton and just put them on top of each other, theoretically everybody could sort of argue that yes, if I did that and I had a pair of them, if I had another set over here, okay, that I would get exactly the magnetic reaction. I would get the idea of the thing would flip around and they would attract. They would behave just like magnets. Alright, so there's a similarity in the function that's just built in to charge and electricity. And the funny part would be is you could argue that there are no magnetic monopoles, that is, there's no north thing that's all by itself, and theoretically there are no electric dipoles in nature, where they're close enough together to be called a dipole, where they would be behaving. All we have is the atom example where we have the negative charge and then we have the positive charge, but there's obviously a distance between them to make the atom, so it's not really a dipole. There are experiments. Now, Franklin asserts that if I take a north side of a magnet and I put an electron here, it won't do anything. Now, I'd argue that you never did that experiment, so that's kind of a moot point. And the experiments we do have, though, kind of show that what I can do to a beam of electrons is I can put them through a magnetic field, and I'll get them to come in and out. Okay, I'll get them to fly in or out of that field, up or down, you could say. So if I put it, it's the wire example, right? This is the way they always do it. They take a horseshoe magnet, and then they put a wire here, and then they run current through the wire in or out, and the wire either flies up or it flies down, depending on which direction it is. So it doesn't go towards the north side or away from the south side, as you would expect. But the trick is they don't do the experiment with just one pole of the magnet, you know, a north-south magnet this way, with no other pole. And if you do that to a beam of electrons, the electrons will go, whoops, wrong drawing. They will go away. Okay, so you can push electrons with a magnetic field. So, you know, this idea of, okay, well, that's moving and all that kind of stuff, well, that's part of the argument, is how does it change anything if the electron's moving or not moving? And the only reason why they say it has to be moving is because of their whole jog about how atoms are constructed and there's a bunch of stuff swirling around, which I would argue isn't the truth. That atoms are magnetically held together. All right, but so is there anything else I need to stress here? So, I mean, there is evidence to talk about, in the sense, what does a beam of electrons do? Well, there's two choices. If I just put one field, I'll either get the electrons to crash right into the magnet. I mean, I've seen it. You know, they stick the magnet on the glass and the electrons fly right into it. If it's a south pole, and I can get them to run away if it's north. But if I have both fields, that is, if I'm creating, see, the idea is they say it goes this way. If there's some field that's moving in that direction. My argument is no, there's two fields. One's moving this way and one's moving this way. So that's why you get the different reaction. There's no... The dominance is what affects electrons, because electrons are easy to affect because they're on the outside of atoms. So the argument is that yes, we have everything drawn based on what electrons do, because electrons are what we can manipulate. We can't manipulate protons easily. So that's why everything is understood as how does it affect an electron. But there really is a whole other side to the story. And there's just as much field going this way as there is field going that way, technically. So anyway, yeah. So what I want to say. So we know that magnetism does affect electrons. So let's not pretend there isn't a close connection. Now the trick is that if I, well, I could just use the example of, I guess which one to go to first. All right, so I'll just explain the charge. So I could put charge on an object. You know, I could add extra electrons, and that's all we're saying a charge is, right? So we're just adding or subtracting a few electrons. And now I've changed the profile of an object to make it plus or minus based on having that extra. And now I try to move that with a magnet. Nothing happens. Now, theoretically, the magnet's saying, you know, at this end is saying electron repulsion. That's the theory. And so it should be repelling that, and that isn't happening, you know. So clearly charge and magnetism can't see each other, is what I would argue. And so the real trick is that the magnet is actually creating a pattern. Again, we're back to, you know, patterns are really important in the universe. And I could make a simple argument that if I had a pattern, you know, of just rings, and the center was dark, you know, and then this ring was dark, so that was this was just an orientation. You know, I can just do it with, you know, a 5-sided dice. I mean, a dice kind of example. So if this one was negative here, and this was positive, positive, you know, in terms of how they were tilted, you could sort of understand that pattern if it was on the surface of something. If I don't have exactly the opposite pattern, I couldn't attract if it was magnetism. So if this was the north end here, this dark stuff was north and this open stuff was south, you could sort of understand that if I took the same, you know, the configuration of another magnet, and it was the opposite, the centers were, well, let's just say, for the sake of argument, they were repulsive. That there wouldn't be any way for the patterns to match, you know, so that would be repulsive. And then the only way they can see each other, though, is if the patterns match. That is, if the other thing has the exact opposite configuration, then there can be attraction. But if it's not the same pattern, there couldn't be. Whoops, that would be open. So this would be the south, and this would be the south. you can sort of get the idea that if the patterns don't match, they have to repel because they'd be constantly seeking. But if they're exact opposite patterns, then they can lock, and now they can attract. So the word locking comes up in quantum, where they talk about just, a superconductor. And what is a superconductor? It isn't just about being a superconductor. It's about being really cold. And really cold means that your atoms can arrange in their ideal configuration because there's very little moving them about. So they'll find their ideal comfort zone, theoretically, when they're really cold. So the colder you make something, the more the atoms are going to balance all of their pressure. So you can sort of understand. Well, anyway, so a superconductor is really what it's doing. It's not so much about conducting electricity as it is, it does that better just because there's no noise to have to plow through. But the point that's really interesting is that it can see magnetism. It does this, Lenz's law thing very well, where it creates this opposing magnetic field, and it creates it completely dependent on what the magnet's doing. So if I have a magnet, a north side, I can make this superconductor just float at any distance I want. I can put it at this distance and it'll lock. I can put it at this distance, it'll lock. Well, I can't say any distance. It does seem to have certain distances that it's more likely to lock at. And that's sort of saying that the superconductor can see the pattern. It can see the bullseyes or the geometry of the magnet, and it's matching it. It's reflecting it, and it's doing it really precisely. And so that's why there's certain places where, by the laws of diffraction and how the pattern spreads, it's going to be able to see the pattern and lock into a point where it's optimized how much of these bullseyes it can match. Say if the bullseyes are different sizes, one's this big and one's this big and one's this big, you can sort of understand there'd be places where you're maximizing how much you're matching the pattern, and then places where you're not maximizing, and then the place where you're maximizing. So that's what I would argue is a reason to think that the magnet's not just creating blue and red, it's creating a pattern of blue and red, of proton and electron force, and the pattern is what other magnets are seeing or not seeing. So a simple charge, just electrons, can't relate to the pattern at all. It's just saying I'm all electrons, and the all electron pattern, is reflecting, but it's not doing it coherently. So it's not respecting the fact that it has to match the pattern, and that's why it's completely inert, because it's just seeing purple still. It's just not matching, to the fact that there's a pattern. And if it matches to the pattern, then it can maximize its repulsion or maximize its attraction. All right, there's no other way to make the context any simpler. I mean, obviously, you really have to get this idea that the universe is just made out of stuff moving the speed of light that never dies. So whatever it goes into, whatever system it goes into, it's always just either pushing or not pushing. So I would use the simple analogy. There's little bulldozers in the universe that never die, that never run out of gas, never do anything. All you can do is slow them down by forcing them to push a boulder of matter, an electron or a proton. So you can slow them down, but you can't stop them ever. And that's the fundamental theory. So when he says, I don't think the force can go through a vacuum, of course I think the bulldozers love vacuums. They got no problem with vacuums. They have a problem with boulders. Boulders slow them down. Vacuums don't slow them down. They got forever treads. But anyway, so that's about all I can do. Somewhere we have to narrow, because obviously I'm unifying based on forces and you're unifying based on matter, and that's really not going to work. I would argue that, I've already argued it. I mean, ether doesn't work because there's no geometry that makes any sense. Can't have straight lines, can't have constant speeds. Just can't happen because your lines aren't the right length. They're on a consistent length. So I'll play a little bit of this. So the point one is that he says, well, the exact words are, let's see, what's he say? He says, not due to, shit, can't even read that. Not net charge displacements. So frankly, I think charge is real stuff. It bounces off of stuff. It forces stuff to move. Blah 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 blah. So I don't. You can't undo a charge. A charge is a charge. It's always gonna. An electron always reflects blue bulldozers, and a red charge always reflects red bulldozers. And that's just the way it is. Anyway. So we'll play some of this. I have to, I played it and I'm like stopping every 28 seconds, and I'd sit here and say, geez, how am I going to say that that's not what I'm saying? How am I going to explain this? All right, so his first argument is electrons aren't affected by magnetism, and I'd argue, yeah, they are, but the circumstances is everything. And then the second argument is he's saying space has to be made out of positrons and electrons. I don't even think positrons are a real thing. So, and I'd obviously say making space out of matter is impossibly messy. There's these huge differences between the strength of just gravity and charge. I mean, right, 10 to the 40th difference in the strength of those two things. How could you fill space full of matter and expect anything to happen? There's too many things in the way.
So there has to be something, even in the vacuum of space, that can represent this vector, right?
Right. Well, the vector is represented by the same thing as representing a photon. So if you get the idea that a photon is a real thing traveling through real space, I'm saying that gravity is a photon with no frequency. And I'm saying magnetism is a photon that's been purified. Okay? That's either a line of blue bulldozers or a mass of red bulldozers. You're either going to push protons or you're going to push electrons. So, but yes, the forces all move through space freely at the speed of light. That's by definition, all the forces. It's the speed of force. Maybe we could just even argue that. Maybe we could go right back to the beginning and just say, do you believe there's any such thing as a pull? All right. I mean, I'm arguing it's a push universe. You have to throw something at something for something to happen, and it's just a matter of a tug of war, in terms of who's pushing on the rope more, and that decides where a piece of matter goes.
And I believe it can't be nothing, right? If space is as empty as Gary says it is, then there should be nothing like a magnetic field, because nothing.
Well, again, I don't believe a field is ever made out of anything other than real force bits, real pieces of radiation. All of it is radiation. That's, and we already know there's a ton of invisible radiation, radiation we don't see. We already know it's there. So why are we pretending this is a hard concept? Yes, space is full of a ton of radiation. The lights are on in the universe brightly, okay, in terms of gravity and other manifestations of the force, right? Well, in terms of just gravity, you could say. It's really bright out there.
Thing cannot represent, a magnitude and direction. So what could represent a magnitude and direction? Well, you could just throw compasses everywhere, and the compass points in a direction, and the number of, I guess how strongly it points, it could be a vector, but certainly something like a compass can.
What would be the relevance of which way it's pointing unless it can communicate where it's pointing? It has to tell something else which way it's pointing. And how's it going to tell it besides sending a force there to do it? I mean, the whole point is that we know all the interactions between everything happen at the speed of light. All the subtle interactions that have anything to do with one piece of matter communicating with another piece of matter over distance has to do with stuff moving the speed of light, frankly. I mean, it's, that's the universe. It has to be communicated. So you don't have a communicator unless you create some kind of force moving the speed of light. And we know it doesn't get knowledge instantaneously. So we know one compass needle doesn't know what the next compass needle is doing until the message is sent at the speed of light. It's not instantaneous.
Represent at least the vector direction. So going back to what I was saying, what space is made of, which is just a positron-electron pair, definitely you have two ends. That thing can represent a vector, right? It's got one end and another end, and so the pointy end can point somewhere, right? So this is another reason to motivate why space can't.
Yeah, right. But there's no straight lines. There's these magnets have to move at some speed. They have to turn. So now you have another obstacle to transmission speed. Um, and that would be completely variable on where it was previously. So now you have to move vectors from where they are previously to where they're supposed to be because you're going to change some other vector. So now you have forces interacting with forces, which, in my opinion, all the evidence indicates you can't move a force with a force.
Not be empty, because there must be something in there that can represent a vector quantity. And a round thing, if space is only consisting of just round spherical objects, this cannot represent a vector, right? At the bare minimum, to represent.
Well, I think it can. You just mark it one half red and one half. I mean, I can make a magnet that's represents a vector that's round. So there's no. But whatever.
A vector, you need at least two things, right, to represent an axis. So that would be one of my main arguments, that since there is this thing called a magnetic field, it's present in the vacuum. All
right, so you're still using the word field. I know you're kind of cynical on other uses of the word field. I mean, what's a field of what? A field of this isn't. There's no reason for anybody to think this field has to be made out of nothing. It's like saying a field of soldiers, but there's no soldiers. You're just saying it's a field. Okay, I'm saying no, you have to make the field out of something. The field is something. And the fields are soldiers moving. I mean, that's what it's made out of. That's right. And they're not stuck to each other, and they don't give a shit about each other. They're all saying, "What's in it for me?"
It has to consist of at least two physical things. That indicates that space itself must be filled with physical things.
So anyway, this logic is not compelling. So again, it's unfortunate that in some ways the conversation is totally derailed because we don't have any common axioms. I mean, for me, it's just clear there's two different kinds of stuff. There's electrons and protons, atoms, matter, and there's little tiny stuff that moves the matter, force. And that's the stuff moving the speed of light, and the matter moves a lot less than the speed of light. Because it has to be pushed by the force. The force tells the matter where to go, and where the matter goes tells the force where it's going to reflect. You could make these kind of arguments. The two are intimately interacting with each other, but they're two separate things.
Now, if the magnetic field is not just a net charge displacement, then
See, that just doesn't mean anything. A net charge displacement. It's something's either radiating blue or they're radiating red. Would be my argument. You're either seeing purple or you can see the red and you can see the blue. I mean, it's sort of that simple. I mean, obviously it's not as simple as just one force, but yes, the universe happens to be 2 + 2 + 2. There's two kinds of force, red and blue. There's two kinds of matter, electrons and protons. And there's two kinds of interactions. You push it, you give it momentum, or the force is diverted. It takes a left turn. That's it.
What in the heck is it? Now, I'm saying that what the magnetic field is, you'll have to look at my paper on the magnetic field to get more details on this, but imagine if you have a positive and negative dipole, right? And then imagine you have a sea of these positive negative dipoles. Now, if these things are all kind of randomly arranged in space, you can shoot an electron through it, and the electron is negatively charged, and it'll be attracted to like the positive charges and negative charges. But because everything is randomly arranged, it's just going to go barreling straight through. It really isn't going to curve or do anything. But instead of the random arrangement, suppose we all line them all up, so that all the negatives and positives are pointing right at each other, right? So if you have a charge, let's say I have a positive charge on this end and a negative charge on this end. So in order for an electron heading straight down to get through, it has to go between the positive and the negative. And what's going to happen is, because this is positive, it's going to attract that electron.
I attract it how? So again, it just there's the point is kind of just becomes moot, because how does it do that? Through what interaction? So you could say, oh, it's bouncing off the compass needles. So first you say you have the field, so you've reoriented all the positrons and electrons in a line, and then you can talk about somehow how the electron now will have to be going the direction of that flow. But I can kind of undo that argument by just pointing out that if I just have a north side of a magnet and I don't have any south side for the flow to go to, it's still flowing
that way. And because this is negative, it's going to repel it away that way. So if there's an electron heading down.
So again, you 1 minute you say if an electron is just sitting somewhere, I can't affect it, and now you're saying I can affect it. So again, what's the catch? And why does the electron care? I mean, you're saying that a moving electron somehow behaves differently than a stagnant electron. Well, why?
Space. It's going to be attracted to the positive. It's going to be deflected. And this is the key. This is what a magnetic field does, is that in the presence of a magnetic field, an electron will deflect in one.
Yeah, I know, but why? So again, we're just back to the why question. How does that happen? And you're not going to really be able to draw a picture of it without a bunch of sparks flying off of everything. So, I'd argue it doesn't work. I'd certainly argue that empty space has every appearance of being quite empty. That it's imitating nothing very well. So why should I presume that it's fooling me by being really dense matter? And it'd have to be pretty dense to move other matter.
Preferential direction. This is the fundamental action of the magnetic field. So if you can create this aligned dipole C, that every single time it goes between these dipoles, it's going to be deflected a little bit. And if it finds another dipole, it's going to be deflected another bit. However, if the charge is just stationary between the charges, it's not going to feel anything. I mean, it will be attracted to the positive bit a little bit more than the negative bit, but it's just going to sit there. And this is why when you...
I don't understand why it would just sit there. If it's if when it's moving, it's going to be bent, why wouldn't it be pushed by the same flow, the same stream? So you're saying I can only get pushed by the current if I push into the current. So the current's going that way, left to right, and I plow into it. You're saying, well, the only way I can be moved by it is I have to plow into it at a speed or something. Why can't I just land in it, and now it doesn't affect me? There's no current. So if I just land into the current, there's no current. But if I push my way through the current, somehow I'm affected. I mean, yeah.
Stick a charge in a strong magnetic field, it doesn't do anything, because it actually has to cut past the dipoles in order to feel any kind of deflection. It has to be moving. And that is why the magnetic force is...
Right. Well, you're saying it has to be, but there's no mechanics explaining how the stream only affects things that are moving across the stream. But fine, that's your rule. You can have a rule. You don't have to necessarily draw me a picture of it, but it doesn't make any sense to me. Sorry.
In direct proportion to how fast the charge is moving, because that determines how many dipole pairs...
No, it'll actually move less depending on how fast it's moving. So the faster you move it, the less it's going to be bent.
It cuts past. It gets a little kick every single time it cuts past one of them, right? So that explains a very important aspect of the magnetic field, which is why a charge does not move at all
Okay, well, I'm just saying you've never proven that one, so you can just keep saying it, but I've never seen an electron not move when a magnet was brought next to a single electron, so you can say it, but I don't buy it. What I would argue is clearly an electron can't see the magnetic, it can't see the pattern, right? So if I did that bullseye idea, and you had the inverted bullseye, it can't see the bullseyes and match up to them. So it can't match the pattern. But what it will see is red, blue, red, blue, red, blue, red, blue. I mean, it will see something that's going to cause it to bounce around, because no matter where it is, it's going to see something. So I would argue it's certainly going to bounce around a lot, because no matter where it goes, it's going to see red or it's going to see blue. It's never going to see purple. So from its perspective, it's either getting pushed away or pulled towards. And the argument would be it's just going to sit there and bounce around in the noise, okay, of the fact that it just keeps breaking into red beams, then blue beams, then red beams, then blue beams, and red beams and blue beams.
The magnetic field if it's stationary, and why does it feel more force if it's going faster, right?
All right, so he says it feels more force if it's going faster. So I'm just saying I don't think that's what the experiments indicate. If that were true, then theoretically, I mean, a cyclotron wouldn't have to keep adding energy to the electrons to get them to go into a tighter orbit. Just trying to think through it. Yeah, no, I mean, it doesn't seem to me that you'd have to show me the experiment where the faster I move the electron, the tighter its orbit. Because I don't think that's true. But anyway, but clearly if it is, so that, well, there's no point in arguing. Clearly if it is, blah, 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 and then we'll find out it's not. So yeah, there's no point in doing that. Clearly, the more electricity you put through a wire, okay, with more energy you can get it to fly out of the magnet. So that sort of makes sense. But you know, that's a wire. It's not a single electron. Anyway, so I guess we can might as well see if we can play through the rest of this.
So in my video there, I was trying to motivate that. Well, why would this dipole C come in alignment in the presence of, say, a wire that has charges moving through it, right? I mean, this is what we see. We see a wire, it's got charges moving through it, and then somehow we register outside of it, well outside of it. I mean, it doesn't have anything to do with the atoms inside the wire. We register a magnetic field. You know, we can drop iron filings, we can put compass.
Well, you're saying it has nothing to do with it, but I mean, I would obviously argue that it has everything to do with it, because you're changing the shape of the atoms when you're moving the electrons, and by changing the shape of the atoms, you've changed them into dipoles. So that's why you're creating a magnetic field, is because you're making copper atoms look like iron atoms.
This is in there. We measure something which we say is the magnetic field, which is distinctly different from the electric field. Because if it was an electric field, you put an electron there, it would just be immediately attracted or just immediately repelled. It would not have to be moving. But it doesn't do that.
Well, again, you say it doesn't do that. I'm just saying, you know, I'm saying it's definitely doing something, you know, so you don't really have an experiment where you can say it's not doing anything.
It's absolutely stationary.
Says you. Okay, so go ahead, show me the experiment where we watched an absolutely stationary electron. So show me that experiment, because I didn't see that one.
But only when it moves does it get deflected. And that can happen in an aligned or polarized dipole field. So as I've always said, you know, and it just is just words, is that as electrons go flowing through the wire, that it basically creates a combing effect. That, you know, like your hair, you just comb it one direction, they all point in one direction, right? And that's...
I know, but you could just redo your experiment and just show the lines of magnetism. So you could say, like, if I was to think of the magnet as being a dipole, an electric dipole, you would be able to see that that's exactly how the compass needles are behaving, as if, all right? Because your magnetic field is always going to be biased in a direction, you know, north or south, in how you introduce it to the compasses. And the compasses are going to see it ahead of time, and the north end is going to go one way and the south end is going to go the other way. So, I mean, you're already setting it up to move in that direction based on the fact that you can't make it an even magnetic field at all locations. And the compass needles are going to be given notice when the magnet's 3 inches away. The compass needle's already saying, oh, okay, there's more north end because it's got the north side of the magnet down, and I can't see the red end much. So clearly it's going to react as if it's a north magnet.
What I need in the magnetic field, that as the electrons go by, they comb the random dipole field into this alignment, such that if I now shoot an electron through it, it will now deflect, right? Because it's no longer randomly arranged, it will deflect.
I agree that electrons deflect depending on the field you produce, but I don't agree that we know which way they're going to deflect. Again, if I put the north-south between the wire, I get the wire to fly out. If I just put a north end, it either sticks or it runs away. So there's two different reactions that have to be accounted for.
So I showed that in my video with the compasses. The compasses are standing in for the electric dipoles. And the magnet that I'm moving is standing in for the electric charge. Now, some people have charged me that you're not showing anything about the magnetic field because you're working with magnets and compasses and not charges. And it's like, well, this is where the analogy part is, and that we know.
Well, I would agree that you can use the two interchangeably, because if I could create the electrical dipoles, they would behave just like magnetic dipoles. And if I create the magnetic monopoles, they would behave just like charge monopoles. So I'm just saying the two things are insanely common, and all we're trying to figure out is, well, why doesn't the electric monopole recognize the magnetic dipole? And I guess I'm arguing kind of overtly that is because we're not really doing that. When you have a whole big magnet, you have a whole arrangement of atoms. It's not a single atom against an electron. Well, then the electron is going to behave quite rationally in terms of it's going to behave. But no, now you're creating an arrangement of magnets, and now the field is very complex. The proton-electron field is really mixed, highly mixed, and the single electron can't see the pattern. You can't see that there's a pattern that's actually that's creating a segregation between the electron force and the proton force. And so it can't see the whole pattern. It can only see, in this tiny location I'm attracted, in this location I'm repelled, in this location I'm attracted. And so it can't go in any direction because it keeps hitting the wrong field. And so it's just stuck, being aggravated, because it can never find peace. So it'll just keep bouncing around from go towards, run away, go towards, run away, go towards, run away. That would be my argument. It's clearly not doing nothing. It's doing something. So to say it's not affected by a magnet, it's not affected in the sense it doesn't go somewhere. It's affected in that it's going a lot of places, it's just not getting anywhere. It's going back and forth.
That the north and south attract each other, just like a positive and negative would. And the compasses act just as they were a positive and negative dipole. So we would expect that if I put an
I know, but you could also just make the same argument. You could just say that you can leave your magnet being a magnet and just say that you're now changing the electrical polarity of the compasses. Because that actually happens. You move a magnet, you create electricity. I mean, the two things are so connected.
Next to a true electric dipole that it would...
I suppose there should be an argument here somewhere that there's really no evidence of anything called an electrical field. That all there is electricity, which is current moving through a wire. So there is no electric field like there is a magnetic field, I would argue. That the only thing you can change is a magnetic field. The radio signal is really magnetism, being a pattern in magnetism being sent.
Would act exactly the same way that a compass would react to, say, a south pole, right? I think that's reasonable. And that if you perform that experiment and you run an electron across the string of compasses, you'll see that they do get combed into one direction. And then when you go the other way, they get combed in the opposite direction. And if you work out, what you would expect to happen, when the field gets combed in the opposite direction, you would find that the force goes into the opposite direction, which is another significant thing about the magnetic field. Instead of the magnet going this way, you comb the field the other way. You predict the magnet will go the charge will go the other way.
Well, again, but I could just say that I could just draw the lines of force, and I could just demonstrate how that's going to happen just based on a simple straight line force equation. Obviously, you're going to swing it this way when you're moving the magnet that way because, yeah, there's attraction and then there's repulsion this way. So, it's obvious it's going to swing. So I guess I'm not seeing how that demonstrates anything other than the point that you're changing the atoms by introducing a magnetic field.
And so that explains why is it when you reverse the direction of the current flow, you reverse the direction of force on the moving electron, because you're just flipping those dipoles and causing the force to react to the other way. And so, like I said, I think this is very significant in that this shows a direct physical analogy. Because I always complain about the dissidents. They dream up this stuff. They think it must work this way, but don't have any physical experiments to show anything that could possibly work that way, right? So, and before, I didn't have any physical experiments to truly justify why is it a flowing current of electrons might comb this.
Well, I think I can make an even more generic argument that atoms tend to have to, just to tolerate each other, neutralize any differences. They have to neutralize any. They balance their charges. Everything has to come out balanced. Okay, you have to spread this whatever repulsion they have to spread it evenly, and whatever attraction they have to spread it evenly. And that as soon as you introduce some kind of other field, that obviously you're going to cause a problem inside of the substance because now it has a new irritant. You've stuck a poison in and has to dilute it. And conductors can dilute it really well, and non-conductors can't dilute it very well, and that's why that's a big difference between the two.
External dipole field into what I believe is the magnetic field, but using just a simple series of compasses and a magnet, I can physically show that is what appears to happen. You run the magnet, and then suddenly all the dipoles are pointing in the direction of the magnet that the magnet went to. And this also motivates the fact.
Well, I think the more important thing would be going back to the Lenz law is that if you just, instead of running the magnet across, you poke the magnet in, what are you causing? You're obviously causing a similar kind of thing that you end up getting a repulsive field back because you're obviously compressing the electrons. Or inverse. Diluting the electrons by pulling them away. So you're either making the electrons more powerful as a force by pushing them together, by consolidating them, you're making them more of a wall, or more reflective, more of a mirror. And when you pull them away from the surface, you're expanding the space between them and making the mirror less reflective.
Be something external to the wire. And it must be made out of physical particles. It's not just like Gary says that the electron is extruding the negative.
It's not extruding anything. So again, that's just horse shit. That's a terrible paraphrase. It's reflecting force. Force is hitting it. It pushes it, and then when another force hits, it reflects. So it always is just. If an electron's moving, it's because force is pushing it. That is, there is force moving it, and another force has to hit it to knock all the forces off. So you can just kind of there's lots of ways to understand it, but I'm certainly not saying electrons just extrude something. They don't create energy. All they can do is reflect the energy around them. They move where the field tells them to. If there's more energy pushing from one side than the other side, then that's the way they go. They have no choice in any matter ever. They do what the force tells them to, period.
Field. That is not enough to explain why is it that the magnetic fields deflect electrons.
No, I'm just saying you can say it's not enough. I'm just saying I don't think you've listened to enough of the content to know whether it's enough. And but whatever, unfortunately, it just seems like, yes, all these conversations get destroyed because if we don't have any common axioms. So until we have some kind of understanding that there's, what the universe is made out of, it just doesn't work. I can unify everything with my theory. I don't think you're going to unify everything with yours, especially something like gravity. But anyway.
Electrons the way they do. There has to actually be something physically out past the wire, which is getting aligned, or something's happening outside, and it's motivated by something that's happening inside the wire.
Yeah, well, I just don't know where you think. I don't think there's a motivator in the universe called force, and that there's a ton of it, because I do. So, it should be back. Let's see if we can finish up here.
So I believe that responds to my 2 things, and I made a way too long video, so Gary should, the science guys should like it. All right, but thanks for sending me that video and commenting on my my other magnetic video. So I'm on vacation now, so I have much more time to spiel about what's going on. So ta-ta. If you have any comments, check out my website, franklinwho.com. and read about my theory of everything, and see just how this entire world fits together, made out of only positrons and electrons.
And some sort of magical fields of some kind. So again, it obviously can't be just made out of positrons and electrons, and there has to be something else, in my opinion. And the difference between matter and space is so dramatic. How could both things be made out of the same thing? I mean, just the density argument alone, it can't make any sense. That, space has the same density as matter, and matter's just swirlier or something. There's more mixed up compasses or something. That's not going to work. So, yeah, no sale really. So, but we'll see where we can go. Like I said, they've got to kind of narrow some of these subjects and get to the real argument, which is what do the experiments actually show? Are electrons moved by magnetic fields? Because in some circumstances they clearly are, and the circumstances is, you can argue about all of these experiments about what you're actually seeing, right? When they put a little bit of a gas inside of a cathode ray tube, are you seeing ions in the gas, or are you actually seeing electrons? These are open questions. So it gets a little complicated. All right, so I didn't have Franklin on. Sorry about that, Franklin. So he was talking to my writing screen, which really wasn't right. So anyway, sorry about that. Doesn't really matter. Nothing much changed in the image. While you missed the parts you missed, there was nothing really dramatic that took place. So I'm going to go to a comment now. Just another one of these idiotic, stupid morons. So he posted this, rude comments. I deleted it. I copied it. I was going to read it. And then he just reposts it, does it right over again. So, and then says even more rude stuff. And his reaction, he thinks my reaction should be, oh yeah, I totally get what you're saying. No, you're an obnoxious liar, okay? And it's disgusting. You're a troll, a piece of shit, a piece of garbage. You have no accountability or incredible. You're just an incredible human being. You just don't know what the word being. You don't know what being credible is. Yeah. All right. You hold yourself accountable. How? So the question mark. Well, I'm here, aren't I? It's my face, my image. I'm a real human being, okay, who has to go through the rest of their life knowing that this is what I've published. Okay, it's a public statement made by me quite clearly. That's accountability. All right, because people can point to it in the future and say, "Oh, look at what he did." So that's accountability. This little trolly crap where you hide behind some fake icon and some fake identity is just horseshit. All right, you are just propping yourself up a fake martyr. There's nothing fake about it. Okay, everybody can see it. You offer $1,700 asking people to try to make a fool out of you and they don't take the money. They make the accusation that you're ignorant. You say, okay, well, here's $1,700. Prove I'm innocent. I'm ignorant. And they won't do it. I mean, it's that bad. I think that is martyrdom. I mean, when they're making accusations and you can't pay them to prove them, that really sucks. All right, anyway. Nothing is genuine substance. Oh, except the fact that I've completely dissected things that haven't been properly dissected in 200 years. You have this magical notion that there's a squirrel that makes running on a conveyor belt and that makes the engine run. No, and I'm showing that no, it's pistons and this and that, gas pressure, whatnot. Has nothing to do with squirrels. All right, I mean, I've totally dissected the two-slit experiment. It's done. It's cooked. As wave theory, it's done. It's over. It doesn't fucking work, and it overtly doesn't work. And I've shown it. I've proven it. All right, and you haven't done anything. I've asked you to give me one fucking link to one fucking video in all of physicdom. So all of the physics world, all of the professor lectures, Lewin lectures, and Al-Kahari, all these people giving lectures, telling us what the truth is. I'm asking you to show me one of them that does it right. One of them that you would stake your reputation on and say, oh, that's really good physics. They really detailed the actual facts really well. Do that, or shut the fuck up. All right, because you're not making the response video. You're not showing the real truth. You're not doing a fucking thing to make a counter argument that's in any way coherent. All right, just talk and fluff that props yourself up as some poser. So again, regardless, I'm paying $1,700 for you to prove that, and you won't prove it. Go get somebody with a little more credibility than you to prove it, and I'm going to give them $1,700. You know, some of you assholes could make yourself some money, right? I mean, you could go to some of these people that have 100,000 subscriber channels, and you could say to them, I'll pay you $1,000 to make fun of this retard. And then you could keep the extra 700. Yeah, you could make yourself some money. Fucking assholes. Calling other people's mothers whores. Well, what else is there to say? I mean, that's about as common, that's about as rudimentary an insult as there is. I mean, clearly cretins on this planet. If there's an asshole somewhere, clearly everybody should be pointing their finger at the parents, right? I mean, we know that assholes are made. They're not born. Okay, so that's no mystery to a scientist. Scientists know that. People aren't born assholes. They're made into assholes. Okay, and then admitting that you produce shit content at the end, really. Well, I didn't say that at all. What I admitted is that, sometimes you have to get a load off. Okay, you have a load of some sort of tension or some sort of load, and it's really nice when the load is taken off, or falls out. That's what I said, shit for brain. But you're too stupid to figure that much out. Really doesn't help your case, by the way. Says you. Okay, says unaccountable bad drawing guy. Okay, wow. I'm so impressed. Unaccountable bad drawing guy says so. Ugh. Alright, wasn't it you who claimed you'll get the Nobel Prize within a year? I don't think I ever said that, but I said, frankly, yes, it should happen, because their physics is overtly bad and rotten, and I was already showing it 10 years ago that it didn't make any sense. That's fundamentally broken. I mean, I could do it in so many ways. I mean, Einstein got the Nobel Prize for proving that light comes in clumps. Well, can't I just undo that by saying what they should have given the prize for was recognizing that we only detect light with clump detectors? Now, would that deserve a Nobel Prize? Oh, we detect light with clump detectors. Because that's the real truth. So as much as I believe that, light is a particle, the truth is the piece of evidence they use to point out that it's a particle is a piece of shit. They didn't prove light's a clump. They just prove we detect it with clump detectors. Okay. And since then, you've changed more than 90%. So that's just an insane lie. That the words on the website haven't changed 90%. So it's just a huge lie. The basic concept is the same. The title is still the same. It's about the photon, stupid. It's still the same. It's still about the forces. So fuck you. That's vile horse shit. My original argument is that the same force that makes gravity makes light and magnetism and all the other stuff moving the speed of light, and that hasn't changed at all. And that's 90% of the theory, jackass. So you're just a liar again. Of your theory, including your theory of how the double slit works. Clearly, my theory of the double slit was always that it worked, that particles were hitting electrons. Now, I thought the pattern had to be created at the slits. I didn't realize, okay, just because you're always dealing with the misinformation that you're given from them. And so I had notions that the pattern was infinite. I had all kinds of notions that were completely wrong. All right, because they had taught me so badly. They had told the truth so poorly. I had fallen for the idea that, oh yeah, the center one has to be a maxima because the two lines are the same length. Well, I didn't realize that, oh yeah, that's a tiny pattern going in, that there's really two patterns in even Newton's scenario, right? I mean, if I take a round disk and I put it in front of a light, I create two patterns. One pattern of rings goes in, and it's really, really small, and one pattern of rings go out, deflects off the surface out. And that creates a really big rings. So you have two patterns created by the same disk. One pattern going in, one pattern going out. And the in pattern is intensely in tiny, tiny, tiny pattern, and the pattern going out is a big, giant pattern. Now that's the physics, right? Now they never applied that to the two slits, so you didn't get the idea that, oh, wait a minute, that central one, that one where there's, telling me that, oh, these are the two path lengths are the same. Oh, that's inside that 1 millimeter. So that doesn't have anything to do with the pattern I'm projecting. The pattern that's getting bigger that I'm projecting on the wall has nothing to do with what's happening inside that 1 millimeter. That pattern doesn't get any bigger. I mean, that's a huge clue to understanding the double slit pattern. Huge clue to understanding the single slit pattern more precisely. Gigantic. All right. And so I'm going to just bury you with that one little observation is so huge that I probably should get a Nobel Prize for that one alone. You dumbass. Yeah. How could they get that wrong for 200 years? How could not one fucking physicist think about it and say, wait a minute, the equal path length is just happening inside 1 millimeter. It's not, it doesn't have anything to do with this pattern. The pattern is 10 inches across. How is the stuff happening inside of 1 millimeter have anything to do with it? Oh yeah, that can't have anything to do with it. That's a fake. All right, anyway. Double slit works, but you probably still think you deserve it back then, even if it was for all the wrong reasons. Well, there weren't the wrong reasons to argue that it's a real force, that forces aren't made out of nothing, they're made out of something, and that photons are in fact a force. They're moving the speed of force. Everything else that we say moves the speed of light, we call it a force. So the one thing that we don't call a force is what we call the speed of force. Which is ironic, right? We say the word light, we don't associate with being a force at all. No connection whatsoever. And yet all the other stuff that's moving the speed of light, none of it's called light, all of it's called force. You see how stupid you fuckers are? I mean, you really can't do any kind of logic, right? I mean, I could point out how physics has 17 different ways to measure the same quantity. A joule, a watt, a calorie, They can't even figure out how stupid that is. All right. Here's what the pattern looks like when you take into account the outer edges. So this is just a preposterous pile of steaming nothing. So this is just hilarious. So I'm just going to draw it one more time. This guy has no fucking clue. Like you say, everyone should. So, this is just so bad. You're just like, what the fuck are you talking about? How is this the double slit experiment? So he has this sine x over x squared plus sine 4x over 4x squared. I mean, any idiot could see the 4's would just cancel out. So what are you even talking about? It doesn't even make any sense. It's complete nonsense. How have you accounted at all? For anything at all? You haven't accounted for anything. It's just such a pile of shit. So, I mean, this drawing is nothing. I mean, that's not even a good drawing of the single slit pattern, frankly. So the simple argument is that you have a slit. The mathematics says there's a distance between the surfaces. Oh, shit. Put the camera on, Gary. So many things for just me to do. So this is a D, actually. So that's the distance they use in the mathematics. And it's perfectly sensible. Okay, there's a 2-point sources, and there's only a certain number of distances based on the number of wavelengths, where you'll have a full wavelength of difference. So whatever number of wavelengths fit into this distance, that is, this is the mathematics. See, this is called a formula. Okay, and so you put lambda there, or lambda, however you want to draw it. And you just multiply the 500 nanometer light, let's say. You just multiply that into this measured distance, and you'll get a number like, let's say 200, just because that's more realistic. 200.5, right? So again, if I get the 0.5, oh gee, is that ever huge. Now, they're not going to show you any video where they take account for that extra, because that extra is basically just saying to you that this line from this point here to this slit, and this line to this slit, that's exactly how much difference there is in those two lines. And there's a 0.5 on there. So guess what? You know they're destructive here. Can't be anything else. And now if you just take an equal line, right? This is your distance L. They usually call it L, but it doesn't really matter. You just take an equal line distance, right? And now I just put the notches right on here. I put these notches on this longer line. And I'm all done. There. That's the 2-slit experiment. So, I mean, that's the single slit. So if I add a second slit, this moron doesn't recognize that now I've created 2 distances. Right? I mean, all I had before was 1 distance. Now I have an extra distance. I have this distance between slits, and I have this distance, this big distance. Obviously, this big distance is going to have a huge number of lambdas will go into that big distance, and a little tiny amount of lambdas will go into this distance. So obviously, these 2 surfaces are going to create the envelope pattern, and these 2 surfaces are essentially accounting for the little bars inside. They're all done. The whole thing dissected as a simple geometric pattern. This isn't about some infinite pattern. This isn't about any of that kind of nonsense. It's the geometry is so obvious. And again, this little fake node inside the first slit, you know, the ones pointing in the same direction. This fake, right? All the others are about lines all going in the same direction. Line, line, line. Now I could make these 2 lines and these 2 lines, but guess what? They're exactly the same as making it these 2 lines and these 2 lines. Same exact difference. But the point is obviously the pattern's being created by 2 different lines in the 2 slit. I mean, I could take a string, right? Oh, you can't see all of that. My bad. Sorry about that. Well, I'll just draw lower. Well, that's a solution. So the point is like I said, this can be understood so simply as all you're saying is, it's okay, let me take a string and between these 2 slits and a string between these 2 slits, right? And I'll just move this string with a pencil through the arc. And I'll move this string through the arc, right? And the 2 will be right next to each other. So these 2 lines will end up right on top of each other. And what am I saying? I'm just saying, where do these 2 have the same wavelength notches? Wherever those wavelength notches match is where you're going to get a bright spot. Of course they match here, okay? When they're all equidistant, you know, these 2 are equidistant with these 2 are equidistant with these 2, you know, then you're going to have a bright, but it's inside of a millimeter. It's not part of the big pattern at all. And the big pattern told you over here that you were at 200.5, and that here, straight line here at 0 degrees, you're obviously going to be 1/2 that, so you're going to be at 100.25. So you know that you're not really a bright there. You're not really in phase. Perfectly in phase is going to be over here and over here. You're going to have to move that 0.25 to get to in phase and in phase. In phase isn't here. Anyway, oh, it's still too low. Okay, my mistake. Well, you can see most of it, so who cares? I've already drawn it so many times that this shouldn't even matter to anybody. But I'm just saying, so I have done the math. I am obeying the mathematical vectors. I'm obeying the geometry perfectly. I haven't committed any crime against the geometry. The algebra and the geometry are all correct. So fuck you. You have no argument here. And this mush equation doesn't mean a damn thing. It's not saying a damn thing. Where are your two distances? The distances, recognizing the fact that there's 4 point sources that account for two different distances. 4 points, you have to define 4 points with 2 distances. You can't define 4 points with just one distance. There has to be 2 distances. Shit. What an asshole. Anyway. This one can go off. Oh, just so bad. Alright. So that's the crap he gets. I'm supposed to dissect that mush. So he says, doesn't look anything like the double slit experiment. That's right, it doesn't. And it's absolute nonsense and it's gibberish. And what the fuck does it have to do with what I'm claiming? Which is the number of wavelengths in the distance of the opening or the impediment or the widest dimension, that distance tells you exactly how many nodes there are going to be. You just divide the wavelength into that distance and it'll tell you exactly how many nodes, how many fringes. Also interesting how you claim you've demonstrated everything you say recreates the math, yet you don't write a single equation down. Well, again, I've done it numerous times. I'm pointing out the simple equation is, if I want to know how long that circumference is, if I want to know how long the arced line is, that's just the simple pi. That's just making the simple argument. You're just placing the straight line radius and you're just converting it into a circumference. So I know that I can just multiply it by 1 pi and that'll tell me the 180 degrees it's going to be projected on. It's going to be projected on 180 degrees. So I just multiply it by pi, the length, whatever the length I decide to do this experiment at. If it's 3 meters, then I take 3 meters times pi. Now I know exactly how long the line is, and now I just divide the rate. Again, I just do the same thing. I just divide the wavelength into that new longer line, and it'll tell me exactly how big each node is. And then once I know how big each node is, I know exactly how many it's going to fit. I mean, it's that simple. All right. Write down a single equation down. Well, again, I've already pointed out you don't even need much of equation. It's so simple. It is so simple. The number of wavelengths that fit in the distance completely controls how many fringes there are. Directly. You don't even have to modify it. It's exactly the same number. You're just putting the same markings on a longer line. You're just taking a ruler that has 12 inches. You're just making something much bigger, and now each inch is 2 inches longer, right? You're making the ruler twice as big, and now each inch is 2 inches. And then I make the 4 feet. Now each one's 4 inches. I mean, it's not complicated at all. All right, just pointing out some basic facts. So they aren't facts. You're just a lying sack of shit. Also, it's incredible how you change the subject when you have no other recourse, which, again, just a silly lie. I would love to just stay on the same subject and keep just pointing out how, wow, how dumb was physics that it couldn't figure out that it's really dumb to say it's the same path length going to that center node when it can't be, if you have a remainder. Unless you have an experiment where I perfectly got an exact number of wavelengths, it can't be constructive. Okay, we're talking about the slits. Remember, stay on the same subject. So again, there is no evidence that I'm looking to change subjects. I've made hour-long videos, 20-minute videos, all devoted to it. There's no subject change. So again, just more lies from these lame, horrible, awful, disgusting people with terribly slutty and dirty and skanky mothers. Ew. The garbage that raised this piece of crap. Ugh. Disgusting. Yuck. These are, 7-Eleven people. Yeah. That's where you camped out, right? That's where you spent Christmas, was at 7-Eleven. Ugh, disgusting. All right. So I'll give you another chance. Try again. Try to make an actual physics argument. And if you can't do that, then fuck off. 99% of my videos are me drawing physics arguments. I don't know you from shithead, and yet you think you have a right to call fling insults at me. Okay? That's just bullshit, asshole. Grow up. Make a real argument or shut the fuck up. Okay. So this is big fan stuff. Okay, so this guy, because I said, because now and then I'll talk about yin and yang as a concept. That there's this idea that things are generally balanced, and then this system ends up getting imbalanced. I don't mean it in any spiritual way. That doesn't mean anything. I'm just using common words to get the idea of balance. When things have an equal amount of left and an equal amount of right, and that kind of idea. But there's no big picture argument here. There's no spiritual or meaningful notion to it. No religious context. I'm stuck with the language as you people have perverted it. I don't have any choice but to use your incredibly non-technical, non-accurate language. Unless I want to make my sentences much longer, where I just use definitions instead of using words. But yes, you almost make me say, okay, I won't bother using that analogy anymore because, I guess they're going to turn that into some kind of religion. Yuck. Alright, so that's enough of a video, I believe. Yeah, it's probably gone past enough, but, yeah. It's all free, so I got no right to complain, really. I mean, I could put a big warning, warning! Video might be a waste of time. I could put a warning on it, but I mean, you really should know that already on your own. That sometimes videos sometimes there's important ones and then there's less important ones. Now, I'm saying there was some concepts in here that were worth talking about, but yeah, a lot of it's redundant. There's no doubt about it.